In this video, we're going to do 8.08 ladybug. So I have the solution right here. Let's just run it to see what we're building. It's going to have a ladybug walk from left to right until it hits the right edge, in which case it's going to turn around and walk the other direction until it hits the left edge, and then it's going to turn around yet again. All right, so I have the file downloaded and opened up in DrRacket. So design a world program that walks a ladybug back and forth from left to right, and then back from right to left when it hits the left and right edge, respectively. The ladybug should also render the facing direction based on the walking direction. Call your structure lady, and hint, we have provided you the ladybug image facing left and right as constants, right? So we scroll down, here are the two constants provided for us. I press Ctrl R, and then type the names. So right -img and left -img. All right, so pause the video and try to work through this problem on your own. I'm going to go for spoilers in 3, 2, and 1. All right, so this is a how to design worlds program. So let's break it down into the domain analysis, all right, to help us think and break things down. All right, so here are the set of constants. Left image and right image were provided for us. We have the width, height, background, speed, and center Y, because it's always centered. All right, so let's just transcribe those constants. So define width. We'll say it's 500. You guys can make it whatever numbers you want. We'll say the height is 200. We'll say the background is an empty scene with the width and the given height. We'll say green to give it a grassy look. What else was there in the set of constants? So background, speed, and then center Y. So speed is define speed. We'll say 5 pixels per tick. And then the center Y, I'm going to put it up here near the height. Center Y is going to be the height divided by 2. All right, so those are all the constants. All right, let's look at our changing information. All right, so we need an X and the speed, right? The velocity to keep track of, because it's going to go this way and then it can go right to left. So we got to keep track of speed here. All right, so pause the video and try to do this step of the design recipe, the data definition step. Remember to call it lady. All right, so I'm going to go for spoilers in 3, 2, and 1. All right, so I assume that you guys took a good swing at it. So we need to keep track of a compound data definition. So define struct, the name of the thing we want to model, which is a ladybug. So we'll call it lady. And it needs an X position and the speed, which I'll call Vx, standing for velocity. All right. And we're going to do lady is make lady give me a number. X is a number and Vx is also a number. All right. How do we interpret these fields? Well, X is horizontal position in pixels. Vx is speed in pixels per tick. All right, next let's write down the signatures. So we have lady-x that comes with the struct definition, right? So lady-x consumes a lady and produces a number. Likewise with the Vx, which is the speed, like so. All right, so let me check myself off for these steps. Description, interpretation, we just did the extra signatures, the examples. So let's come up with some example data. So to find L0, we'll say make lady starting at 0 and X and then speed. So this is a ladybug starting way left and walking right, all right? So it's this image right over here is what we're describing, all right? Let's do one more example. So define L1 make lady width, and then we'll do negative speed. All right, so this is the opposite one. Starting way right and walking left. All right, so those are the examples done. Let's move on to the template. Let me check myself off for the examples. So the template, let's just sketch out what, any function that processes a lady needs to do. So lady temp, call the parameter LD, and it's probably going to need to take apart its fields. So like so, Vx LD, and that is the template. All right. So now let's move on to the function step. So functions, let's go back to our domain analysis. We identified we only needed onTick and 2draw. So let's delete all the other options we don't need. We don't need stop when, we don't need onKey, and we don't need onMouse. All right. Next, let's rename this WS to be lady, because that's, what the new world state is. So replace, skip the parameter name because we can do that manually later. There we go. And like so. All right. So now we have a to-do list of what to do, right? We have onTick and toDraw. In fact, I'm going to rename tock to advance lady because that's more descriptive and representative of what it does, right? Just better naming helps, keep things clear in our heads. All right, so now try to work through the advanced lady function, also known as the tock function. I'm gonna go over spoilers in 3, 2, and 1. All right, so I'm assuming that you guys took a good swing at it. So don't, don't fret if you, don't get this right away because it's a sort of math-ish heavy concept. I guess draws upon algebra and, graphs and stuff. Anywho, let's go back to our domain analysis to help us out. So really there are 3 cases, right? One, when it's traveling in the middle. So it's traveling like right in the middle or left in the middle. Well, not really in the middle, but like not hitting an edge, right? So that's one case, not hitting an edge. Yet 2 other cases are hitting an edge. So this one over here, where it hits the right edge, and this one over here when it hits the left edge. So it's these 2 cases that really need more attention because this is just x plus speed. Right? That's it, right? If you have a negative speed, you're going this way. You have a positive speed, you're going that way. So we can imagine that that's just incrementing x by the speed. These 2 cases, however, are a little interesting. So this is trying to go beyond the width. So it's still trying to move this way off the screen. So if it tries to move off the screen, right? So we'll say this is the width. So let's say it tries to move, past the width like 505, and the width is 500 currently. So if it tries to move to say like 505, like right about here, right? We're going to snap it to 500 and we're going to invert its speed like so. So it can go walk back that way. All right. Let me do the same for the left side. So let me just Control Z this. For the left edge, it's the same thing, right? This is 0. And if it tries to go to -5, so maybe it's like somewhere here, right, we'll say that's -5. If it tries to go to -5, we say, hey, no, that's way beyond 0. That's way beyond the left edge of the screen. We're going to snap you back to 0. And then we're going to negate your velocity, right? Your speed, so that you can go back and walk that way. So this becomes that. All right. So now that we have our 3 cases down, we have, some sort of headway as to where we're going. So signature, purpose. So first case is produce lady incremented, lady X incremented by speed. Well, we'll say going at speed. Going at its speed until it hits the right or left edge, in which case snap its position and negate its speed. We'll say Vx speed is what I meant. All right. So signature, purpose, stub. Let's finish the stub. This has to produce a lady in the end. So we're going to do make lady of 0 and 0. All right. Next are some examples. So the 3 cases I stated, check, expect. We'll do the middle one first since it's the easiest. Advance lady, say make lady 200. So it's at 200. So it's like somewhere, we'll say here. That's like 250 though. So we'll say 250 and it's moving at speed. If it's moving at speed, it's going this way. So that means 200 plus 200, its current position, we'll say that, plus its speed. So since the speed is positive, because we're going that way, it's positive 5. So the position it should produce, the lady it should produce is 205. All right, so advanced lady going at a positive speed, right, or constant speed over here, should produce a lady going at an x of 205, same speed, right? Because we don't want to negate, we don't want to do anything to its speed until it hits the right or left edge. All right, so let's just keep going. Let's do one case where I guess it's negative speed. If it's going, 200 at negative speed, then this should be 195, and the speed should still be negative. Right, now let's do the edge cases, right? The left and right edge. So we'll do the right edge first. So let's say it's trying to go, plus with speed, right? So it's trying to go, you know, a little past here, right? That means we want to snap it to 500. So there we go. It's already going at a positive speed. So we want to snap it to 500 or snap it to the width. And then we're going to say, hey, your speed now has to be inverted, so it has to be negative. All right. So now let's do one more example for the left edge case. So let's see, a ladybug that currently has, we'll say, you know, -0 speed. That should be -5. And, you know, the speed is already negative. All right. So actually we'll do plus negative speed. That is kind of more, a little more clear in some ways. So that means its speed is going to be -5, right? Or we can write it the long way. So we'll say, wait, no. So we're going to have to produce a lady. So right now it's at -5. So we're going to snap it to 0 and then flip its direction. That's what I meant. So it's, you know, it's trying to go beyond 0. So -5 right now, we're saying no. We're snapping at 0. We're going to produce a lady with 0. And let's see, the speed has to be inverted. So it's going to be a positive speed now. All right, so those should be our tests. Let me run our stub against our test. Empty scene is not defined. EMPTY. Whoops, spelled it wrong. So there's our T. There we go. And we just get some mismatches, which is fine. All right, so let's grab the template and start cracking this down. Copy the template, paste this in, and comment out the stub. Rename the template to Advanced Lady now. So now really pause the video. This should be all the mental scaffolding needed to solve the problem. I'm gonna go over spoilers in 3, 2, and 1. All right, so I'm assuming that you guys took a good swing at it. So let's see, we're gonna have to do 3 cases, right? Because there's the case when it's walking in the middle, right? Not hitting the left or right edge, when it hits the left edge, and when it hits the right edge. So let's do the edge cases first, right? So when it's X, so we're gonna grab the X position, is greater than the width, right? We want to do something. Likewise for 0, so when it tries to be negative, like so, and then otherwise it's traveling in the middle, like so. All right, so I'm gonna do this kind of more iteratively, all right? So we know at the end of the day, the advanced lady function has to produce a lady. So these branches has to make a lady. Lady, ... And let's do it for all these other ones. So make, so 2 ... because there's 2 fields. And we'll do one last one over there for this last case. All right, so let's handle the first case. All right, so let's see, if you're greater than the width, if the X position is greater than the width, we want to snap it to the width, right? So its X has to be snapped to the width, and its speed has to be negated. So we can grab the speed out of the ladybug. So we're going to say, you know, there we go. We're going to multiply -1 times the speed, right? So if its speed right here is +5, right? So that's +5. If we multiply it by -1, we should get -5, which is going to go back that direction, right? So it's going to be walking this direction, like so. All right, so that's pretty much it. Let's move on to the second one, the second case here, where it's less than 0, right? Well, if it's less than 0, that means it's way over here. We want to snap you to 0. So let's just put that your X is now snapped to 0. And you have to go at a positive speed now, all right? So we'll say that since it's going this way, right? It's heading, all right, well, this picture here, we'll say this has a position of 0 and a negative speed. So let's say -5, right? If we multiply it by -1, that will equal to +5, which is just the number we need so that it can go back and walk this direction. All right, so its position is snapped, and we're going to multiply its speed by -1 so that it can walk the other direction. All right, so pretty much this yet again, up like so. All right, otherwise, right, this is when it's walking, you know, not touching the edges. Its X is just going to be plus these 2. All right, and its speed is going to stay exactly the same because we only want to flip the speed when it hits the left or right edge. And we can remove these two template variables, things that were, there, so that we don't have to, wonder, hey, I didn't know we could use that. All right, so we run, all the tests should pass, and so they do. All right, so now let's move on to the render function. So pause the video and try to work through the render function on your own. I'm gonna go with spoilers in 3, 2, and 1. All right, so I'm assuming that you guys took a good swing at it. So this function's job is to produce the image of the ladybug at its given X on top of the background with the correct facing direction. All right. So signature, purpose, stub, we can use empty image because at the end of the day, this has to produce an image. So we can use empty image or, a square of 0 pixels, etc. All right, so next is the example. So check, expect, render. So we'll say make lady, we'll say, 200. So it's somewhere in the center, right? The X is in the center. And we'll say we're going at speed, any positive speed. So it's going to be something like this image here. All right. So what do we want to do? Well, we want to place image. There we go. Let's see. So if the speed is positive, then we need to make it face right because positive speed is going left to right. So we can use the right img, and its X is at 200. So we have to place it at 200x. Center Y, because we want it to be centered on the Y-axis and on top of the background. All right, let's do another one facing the rightward the leftward facing direction. So we'll say, we'll say 100, right? So 100, that's where the X is, and it's going at a negative speed. So it's going at negative speed. That means we want to use the left facing image. And yeah, let's do the edge cases. So when it hits the left edge, so when it hits the width and it's going at a positive speed, right? We'll say we have to draw at the width. And then if it's got a positive speed, then we have to use the right image. All right, and then we'll do one more using the left image with the 0 this time. So 0 going at a positive speed. Well, we'll say negative speed. So that means it's going to be like these cases here, right? Where it's half, stuck out. You could do one where it's like here and then, another test where it's like this. All right. But for time purposes, I'm going to omit that test. But if it helps you, work through the render function, then I highly recommend you do it if you're like stuck writing the render function. All right, so 0 going at negative speed means that we have to place it at 0. And going at negative speed means right to left, so we have to use the left facing image. img. All right, so now let's run the render against the stub, and we get mismatches. So this is sort of the middle case I was talking about. So left to right, and it's going that way. Here's another one, and here's where it's halfway, and the other one where it's halfway, right? With a, what is this? So this is, all right, this right one is with a positive direction. So with a negative direction, it should face, this way instead. And likewise with this one here, right? 0 with a negative direction. So if it's a positive direction, it should draw this, sticking out here. All right, so let me grab the stub. The template. Let's scroll down here, rename it to render. Comment out the stub. All right, so now really pause the video and work through the solution on your own. I'm gonna go with spoilers in 3, 2, and 1. All right, so that just should have been most of the mental scaffolding needed to solve this problem. All right, so we can see the two changing parameters are left image and 0. The rest are not changing at all. So let's see, we'll do a place image. All right, so let's, ignore this left image and right image, right? We'll just always use the right image for now. All right, and it has to be placed at the given X, all right? And then what else? Center Y and then the background. All right, so this, we have to use this for the changing image over here. I'm going to use that shortly, but I'm trying to do this iteratively, so you know, we can always work on it later. Let's just see it in action first. So some tests fail, and we can main make lady of 0 with positive speed. We can see this in action. So there it's going at positive speed, but notice how it doesn't change its facing direction, right, to the left facing one. So this is what I mean by, you know, since, you know, this is a how to design worlds program, you can run your program to see the bugs instead of relying on the test sometimes, because sometimes your tests aren't going to, you know, catch all the cases here. All right. So that means, you know, it's based on the VX, because if VX is positive, we have to go use the right facing one. And if VX is negative, we use the negative facing one. So we can translate that, you know, very quite literally. So if positive VX, then we can use the right facing image. Otherwise, that means you're going left. And that should solve the problem. There you go. All the tests should pass. And so they do. And if I run, we should get our program behaving as expected, like so. All right. Thank you for watching, human. If you wish to interact with more of your kind, join our Discord linked in the description or on screen. If you want to aid in my quest for world domination, consider hitting the sub button. Thumbs up if you enjoyed it, thumbs down if you didn't. Any questions, comments, or suggestions, fire away below. Also, check out the annotations on screen for the next relevant video.